Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 440, which is fruits into basket 2. So this problem is same as the first problem, only the constants are different. So let's discuss the problem statement first. We are given two array of integers, fruits and baskets, each of length n, where fruits I represent the quantity of the fruits in the basket I. And what we have to do, we have to, here are three conditions given. Each fruit type must be placed in leftmost available basket, which has a greater capacity, and each basket can hold only one type of fruit. And if a fruit type cannot be placed in the basket, it remains unplaced. And after doing all the operations, we have to return the number of fruits that did not get a basket. Okay, so how to solve the problem? So for the first problem, where so let's take the first example. Let me take the first example, then I will discuss the solution ideas. 4 to 5 and 3 2 3 4. Let me write it. Uh, Let me copy this thing. These are the test case, first test case. So fruits is 4 to 5 and basket is 3 5 4. So we try to put the first fruit in the leftmost available basket which has greater capacity. So this basket is the leftmost available basket which has a greater than equals to capacity, which is greater than equals to 4. So we put 4 in the first fruit in the second basket. And now this basket is picked with the first fruit. So let me write 1 here. Now for 2, we will try to find what is the basket, what is the leftmost available basket we can put this. So the first basket has a capacity greater than equals to 2. So we can put the second fruit in the first basket. But for the third fruit, there is no available basket which has capacity greater than this. We can't take the second basket again because we have already taken this for the first fruit. Okay, so this remains unplaced. So number of unplaced fruit is 1. Okay, so our answer will be 1. So after seeing this, the first problem which has a constants like n less than equals to 100, number of fruits less than equals to 100, and number of baskets also less than equals to 100, we can think about brute solution of finding, try to find basket for each and every fruit. Okay, so how? Okay, let's discuss the order of n square approach, the brute force approach, which will work for the first problem of this contest. So we'll iterate over every fruit. So let me write it in the code format. So we'll, let's say, for every fruit, so let's call it for protein fruits. What we'll do, we'll try to iterate over each basket. Okay, so let's say we iterate over basket in baskets. Now if we'll check that if basket has, if the current basket has greater than capacity of the greater than equals to fruit, it has higher capacity, then what will we do? We'll just mark this basket as basket. This basket will be marked as, let's say, -1. That means this basket is already picked. And in the for the next fruit, if we try to pick the basket, this condition will not satisfy. And if for any fruit this condition, let's say we mark a flag as 1, let's say flag as 1. If any fruit after the for loop is over, let's say if flag is 0, then we'll just increment our answer variable by 1, because flag is 0 means that this fruit is unplaced. I hope you get the uh, pseudocode for the first problem, the order of n square solution. Now we will try to improve this solution to work. Okay, because in our current problem, it, okay, so okay, sorry. Let me fix this. I think I have opened the first problem only. Yeah, I have opened the first problem only. That's why the constraints are okay. Let me take some time. Okay. Um, so I have opened the problem, puts into basket 3, the second version of the problem. Here the n is 10 to the power 5. So the our order of n square solution will not work. We have to think something in terms of order of n, or it could be order of n log n, or I have solved this problem in order of n log square n, order of n log square n. I think there could be better time complexity for this problem. Sorry. But I have solved this in order of n log square n. So how I am solving this in order of n log square n? For that, I have to discuss one data structure which I will not discuss in detail, but I will provide the link of the article in the description box, which is segment tree. But what segment tree does, what we can do, we have, let's say, an array from L to R. For those who don't know, if you know about segment tree, you can skip this part of the video. We can find the range maximum between L to R. We can find the range maximum between L to R using segment tree, right? And we can do point update for a particular index I in the segment tree. So two operations. One is this is query for max, and this is update, point update. For range update, we have to use lazy propagation, but for this problem, point update will suffice. Okay, we'll do range query and point update for this problem. So we'll use segment tree, normal segment tree, which will find give us our maximum. Okay, now what will be our solution approach? So let's discuss the solution approach. So for every fruit, okay, for every fruit we will try to find, we'll do a binary search. Okay, we will do a binary search. How binary search will work? So let's say we will try to find, let's say we'll fix a mid value. I hope you know about binary search. In binary search we fix a mid value, and for this we will try to find what is the max range maximum between 1 to mid in the basket. Okay, in the basket array, what is the range maximum from 1 to mid? Okay, now, if this range maximum is greater than equals to, if the range maximum is greater than equals to our current fruit size, then we can surely say that one basket which has a greater capacity lies in the range 1 to mid. Now we have to shrink our mid value. We have to shrink our mid value to find the exact index. So now our right value will be now made. This is standard binary search. Right value will be made, and we will again do binary search. Okay, and after every operation is over, we found a particular mid value which will have capacity greater than equals to a5. After that, we will update. We will do point update for that mid value and change the value of that index to -1. Okay, that will be. This is the first operation. We are doing a binary search to find the exact basket value which has a capacity greater than a5, and after that, finding the mid value, we will update the current mid by -1. Okay, that is the what we can say, that is the second operation. So we are doing binary search. Why our time complexity is order of in log square n? We are doing a binary search which will give us order of log n, and in binary search we are doing a get operation on the segment tree for 1 to mid, which will again give us a log in time complexity. So inside our for loop, where we are finding basket for every fruit, we are doing a order of log square n operation. So our overall time complexity will be n into log square n. Okay. So let's jump into the code. I will not explain how segment tree works. You can check Geeks for Geeks or CP algorithms for detailed explanation. I will just explain you how I have used that segment tree. You can think the segment tree as a black box. Okay. Uh, so this part is the segment tree. This part is segment tree. This is copied from Geeks for Geeks, and this gate max will give us the max in the range L to R. Okay, now what we are doing, we are updating every value of the basket I for a particular index I. Okay, now we are iterating over every fruit value and doing the binary search. We are fixing the range from 0 to n minus 1. Now we are checking the mid will be get mid of L to R. Now if the max from 0 to mid, let's say the max from 0 to mid is greater than equals to AI, that means we have found a value. So we'll change our race to mid, and we'll shrink the we'll go to the left part because we have found our mid. So we'll go to the left part. But if we have did not find our mid, then we'll go to the right part to find the mid. Okay, this will be increasing function, right? Because we are taking the range max, so this will be increasing function. So if the mid is not found in the left part, we can there is a possibility that we can find it in the right part. Okay, now after we are initializing race with -1, and if the race remains -1, that means we have not found any max value which is greater than equals to AI. So if race is -1, that means this fruit will remain unplaced. Okay, so we will do answer plus plus. Otherwise, we are updating the race value because the basket race will already be taken by this fruit. So we will update this race value by -1. Okay, I hope you get the explanation. I will provide some link where you can learn about segment tree if you do not know about segment tree. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. I will also provide the link of the code in the description box. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.